By the end of this video, you will have an understanding of how to implement a movement controller script for our platform game using Unity and C#. For the best tips and tricks on game programming and game development, subscribe to my channel and hit that bell icon to get notified when I upload new videos every Monday. If you're already a subscriber, thank you. It really means the world to me. Hi, my name is George Wulfers and I'm a professional game developer. Let me guide you on your game development journey. Be sure to watch this video to the end to find out how you can get more free learning resources. Step number 1. What's a movement controller? The character controller, or the movement controller, or whatever you want to call it, it basically handles movement of the player. So it's a separate script, and you attach this script to any object that you want to move. And the purpose of this character controller or movement controller is to allow to handle collision against pretty much the world or the environment within a game. For example, if you were to jump and land, it will pretty much tell you whether or not you're standing on a surface, or whether or not you're in the air, or whether or not you have collided against a wall or against any other items or anything else, probably as well as enemies. In Unity and in Unreal Engine, if you're using Unreal Engine, they have their own script for you, or component for you to add. It's called the character controller in both instances, I believe. But here we're going to show you how to make your own. Step number 2, implementation of the movement controller.
Okay, so let's navigate to the scripts folder within your Unity project, and let's go ahead and create several folders. Inside of gameplay folder, we're going to create another one. And within player, we're going to create a C# script. And let's open it up. Okay, so as always, we need to have our namespace, which is going to be Wulfers Games Platformer Gameplay and Player. If you're ever confused about this, just look at I usually, um, based on this, or based on the folders, that's pretty much what I do with the namespace. But let's move on. So this movement controller is going to be inherited by monobehavior because we want it to be used as a component so we can use it in any object. Okay? And some of the properties or variables that we will need are speed, so that we can move the player, gravity, so that we can fall and jump, drag, so that because we are using our own physics and we are using actual physics of motion, if we didn't add drag to it, we would just accelerate or keep accelerating infinitely, and we wouldn't be able to stop unless we were to counteract in that um, the opposite force of where we're going. Um, there is this law in physics that states that anything in motion is going to stay in motion unless there's an opposite and equal force um, applied um, to it, just on the opposite direction. So we need drag. Pretty much drag is going to be a scalar for that force that is going to act against the actual velocity that we have here. So we need a vector 3 velocity. All forces are vectors, as you will see later on. And we need a flag to see if we are touching the ground or if we're falling. So if grounded is false, then that means we're not touching the ground, we're falling, or we're trying to jump or something like that. And if it's true, that means that we are safely landed. We safely landed and we're, walking or whatever. Um, then we need a jump speed to be able to jump and a max jump height along with another boolean to allow us to know if we want or if the user wants to jump based on the keyboard or whatever they press. And then we have these, which starting jump Y or start jump Y is just whenever we jump, as you'll see later on, we're going to be using this to actually to calculate how far we need to jump from there, from that current position, to allow us to use that max jump height. We're also using a rigid body 2D at the moment. I'm not sure if we can go around and not use it. I believe we need to use it if we want to use the built-in on collision enter 2D functions and exit 2D functions. I'm not too sure. I will check that, but I really want to use it as the least amount as possible because we want to work on our own physics so that we have as much control as we can when making these systems. And then we have the direction. This direction is going to be pretty much the direction that the player wants to go, whether it's to the left, to the right, or up if it's jumping. And so in the start, all we're going to do is we're just going to get the rigid body 2D. And if we do have it, we're just going to set the mass to 1 and the gravity scale to 0. We don't really want to use gravity scale because then it's going to mess with our own gravity. It's just going to add double gravity pretty much. Ours and then the rigid bodies, Unity's version of that. Once we figure out if we don't need to use it, then we can just get rid of it. But for now, we need to turn it off. So here we're going to have two separate update functions. And if you don't know what the differences are, go ahead and go to the link below in the description to get the PDF, our free downloadable guide where you're going to learn pretty much what the differences are between update and fixed update in a more detailed uh, fashion. And I'll also include other links for Unity to so you can further read on what those are. But essentially, what they are is the update loop updates every frame. So this is where you're gonna have everything. Um, it's gonna pretty much you're gonna have, run that functionality once every frame for every object. Now the fixed update is usually um, you can set, I believe you can set the time that it runs at based on the physics time scale, I believe. Um, but I'm not sure right now as how far, um, well, I guess it says fixed frame rate, so I guess we can't, but I'm guessing we can because you can I think you can mess around with like the time scale. I don't know if that actually messes with it, but we'll see. Um, but essentially what this function does, this fixed update does, is it doesn't run every frame. It runs like it says at a fixed constant rate. I mean, eh, while this one tries to update itself as much as it can. And like this one is not based on the frame rate. That's why we need to use, whenever we do things within this function, we need to use the delta time to actually scale it down and be so that because if you had a program running on two separate different computers, the same program, just two different computers, one more powerful and then the other one less powerful. If the CPUs don't run at the same rate, you're going to have different frame rates. So that's why we use the time delta time when we're moving around so that you can have as much control as the update rate, I guess you could say. But this function does not, it doesn't guarantee it. This function doesn't guarantee that you're going to get a smooth frame rate in every computer. I believe this one does. This one is fired at a fixed update, like it says. So this, it usually, because of physics, you do want everything to be constant, and this function does that. But the what this is mostly used is for physics updates. So this is why we have all of our physics within this function. Um, okay, so let's go ahead and explain what is going on in here. So pretty much, we want to reset the direction every frame because it is gonna determine where you want to go based on the input. Here we're pretty much just checking to see if the player wants to go left or right here. Um, and we change the X direction based on where they want to go. Maybe later on we can, instead of hard coding these keys, we can create a controller, um, kind of like we did in the previous project where we had our own controller or input controller, where you could set the key bindings for whatever actions you wanted. We could do something similar here. Um, and here, if you want to jump, if you it, when you want to jump, you have to check if, well, that depends actually if you want double jumping or not, but we don't at the moment. We'll see how we can implement that maybe later on. But right now, we only want to jump when we're on the floor. So we don't want to jump when we're like in midair. And we don't want to jump if we've already started jumping. So we don't want to double jump. So if all of these, if all of these are true, or yeah, if all of them are true, then we want to set um, wants to jump to true because we the player wants to jump, and then we just set the direction to to be 1 on the Y because we want to go up, um, and then we just take a note of what the current Y position is so that we can on the physics update we can actually check to see where that is going to go or how far up that's going to go. So the next part is the physics. So we are pretty much just using the equations of motion, which we use to, we use that or those functions or those equations to um, model um, a proper physics, I guess you want to say, so that of acceleration. So we're pretty much how this works is we get the direction and then we just want to times that by the speed. And that's going to be the acceleration. The acceleration in the equations of motion, I believe, is just a constant. But we want to make it dynamic. So we want to, based on the player input, we want to allow that to change the acceleration. So we can either be running super fast, walking, or not doing anything at all. And we should see different types of behaviors based on the acceleration or the input. Um, and here, pretty much what we are doing here is just we're saying if we're not grounded, if we're not on the floor, we're falling. So we're applying gravity here. And after that, if we do want to jump, pretty much we're just checking the Y position of the player and we're checking to see if that is less than or if it's greater than the max jump height based on the starting point where he jumped. And if it's less than, we're just going to keep on jumping right here. But if it's going over that, then we are going to say that we stopped. That if we reach the top of the arc, then we're just going to tell it, okay, we don't want to jump anymore. So we're just going to reset everything here. And then gravity is going to kick in and is going to bring us back down. Okay. Now, this is probably not the best way of creating a jump. And what I want to do next is probably create a better jump with a parabola, which we will discuss in further detail later on, but not here. So pretty much here in this line, we are applying that drag. So we are trying to slow ourselves down as much as we can based on the velocity or the opposite actually of that velocity scaled obviously by that drag. Um, and to apply the velocity based on the acceleration and time, all we got to do is um, get pretty much half of the acceleration times time delta time squared plus the velocity times the time plus the old position will give us the new position. Um, I will explain this in more detail in the PDF, and I'll probably link to some articles that speak about it. so you can learn more about it. And the velocity is just going to be the acceleration times the delta time plus the velocity or the old velocity. So this is the old velocity and this is the new velocity, which I'm just writing it like this because it's way easier to visualize than if we just do plus equals. But plus equals is totally valid as well. Um, but yeah, that's pretty much how you add acceleration, gravity, and drag physics to your object. Um, and we'll pretty much see it in action in a little bit. All we're doing in these functions is setting the is grounded to be true or false and resetting the velocity for the y because we don't want to keep on falling once we are in the ground, or we don't want to keep that y offset in the that will drive us into the ground. We just want to be above it. So um, we're just clearing the velocity in the y. Um, and this doesn't really matter here. I think I was just checking something when I was programming this. Um, just with the playing with the gravity scale, but yeah, we don't want the gravity scale as I said earlier because it's gonna add double gravity into our game. Now the only thing that's probably missing from this is getting the actual weight of that object if we wanted to, so that different size objects can fall at different rates based on, the gravity pull of whatever planet you are. So we'll see if we want to add that later on. Now, why are we adding, if you're wondering why we're adding actual physics to our game, that's because it's going to add more, it's going to allow us to have a smooth or smoother set of controls and whatnot to the player. If you have noticed before in other games that you have played where you have a player and it the player just feels super heavy, it's because they don't use physics, they don't use proper physics, and it doesn't really match what we have experienced, at least as humans. And but it's always good to start, even if you're not gonna model your your physics to the T based on real physics. It's still good to have these physics equations in here as a starting point, and then you can tune it however you want it based on whatever the game you're making is a good thing because it gives you a solid foundation from where to start, and then you can just, tweak it to get whatever you want your game to feel like, but still have good enough physics controls that make your gameplay funner and not have, your characters be sluggish or heavy or, you know, not functioning very well.
All right, I hope this is making sense. Let me know in the comments below if there's anything you are struggling with. Step number 3, testing what we have so far.
All right, so let's go into the demo scene that we have inside of our scenes folder, and we are going to need to create several objects. So the first object is going to be our player, and we'll just tag it player. We're going to make sure that he starts at 0 at the origin, which is all zeros, and we are going to just use the knob sprite for now, and maybe that's too big. Then we're going to be adding a circle collider to D to it, and make sure it fills it up properly. And we also need a rigid body to D. Make sure it's dynamic. Mass, angular velocity, we're going to set that to 0, and the gravity scale, we're going to set that to 0 as well. And now we need to create other sprites. This one is going to be called ground. The sprite is going to be the UI sprite for now. And instead of simple, we're gonna say it's tiled. And we're gonna do something like that, maybe. Maybe a little bit bigger on the width. And we're gonna do a box collider to D. And this one we will need to change. So pretty much to change it, we just click on this button right here. And once it is pressed, you can see little controllers on the viewport or the scene view, and we pretty much just want to make sure that the whole sprite or image is covered with that for now. Once you're done, make sure to unclick it and save that, and we can just create several ones to just move them around as needed. And that should be good enough. Now, the other thing that they need is a tag. So we're gonna set it to tag ground. If you don't have that tag, go to add tags and click on the plus sign, type the name, and then go back into here and choose it from the drop down menu. We're gonna move the player to, I don't know, be up there. And one last thing, we need to add the movement controller to our guy. We want the speed to be 10, gravity to be that. We'll set the drag to be 2.5. We don't need to do anything with velocity or that. We just need the jump speed to be maybe 10 and maybe 2 there. Let's hit play and see what happens. Alright, so as you can tell, we are properly using the physics, and the jump is okay. We will need to work on the jump a lot, which most of the time jumping and all of that stuff it's not just you do it once and then that's it. You have to refine it every time. You have to pretty much iterate through it a lot to be able to get to a state where you're happy with it. Now let me show you something about drag. So let's take that to 0 and let's just move it to the right a little bit. And you're going to see that it just moves pretty much until you reverse that velocity. So, and if you add the drag again, you can see that it slows down until it stops.
Congratulations! Now you know what a movement controller is and how to implement it using Unity and C#. If you would like to follow along, I have provided a link to the project in the description below. Don't forget to also get our free guide where we explain in more detail what a movement controller is in the description below. And before you go, check out these other videos on how to make a 2D game using Unity. If you like this video, hit that like button and be sure to subscribe and share this with your friends. Thank you for watching and see you guys next week. Have a great day and be safe.